Good afternoon, ladies and gentlemen. Today's topic is using the Pythagorean theorem, which you guys are getting pretty good at, in 3 dimensions, which is a little bit trickier, but only because it's sometimes hard to visualize what's actually happening. So our goal today is that you can apply the Pythagorean theorem in 3-dimensional situations, such as finding the diagonal of a cube or rectangular prism, or the slant height of a pyramid. And those are probably words that you're not very familiar with, but in a few minutes you will be, so don't panic. Okay, so slant heights on a pyramid. This is a pyramid. This is an attempt at a 3-dimensional drawing of a 2-dimensional drawing of a 3-dimensional object. So back here, this would be the back wall of the pyramid. Okay, don't actually scribble that out. I'm just showing you guys to try and help you visualize it. And then the bottom is this surface here. That's the bottom face of the pyramid. It's the base of the pyramid. And then each one of these triangles is one of the sides of the pyramid. So when we want to find the slant height of a pyramid, what we're actually looking to find is if you were to stand on the surface of the pyramid and walk up the pyramid, up one of the slopes, maybe it might be easier to see here, walk up the side of the pyramid, straight up to the tippy top, that's called the slant height. And that's because it's at a slant to the ground, because this is the ground level, right? And you're kind of walking up at an angle. You're not walking straight up, you're walking at a slant. All right, now the vertical height of this pyramid would be from the very tippy top here. Of course, my pen is awesome, so bear with me. The very tippy top, right here at the top, all the way down to the center of the base, okay? So from the top to the center, but that's not what we're looking for. We're looking for the slant height, which is across the face of the pyramid. We're going to use the vertical height of the pyramid along with half the length of the base. And together that's going to form a right triangle right here that's kind of buried inside our pyramid that will tell us the slant height of the pyramid. This is really useful for situations like surface area calculations, because for surface area you have to find the area of each face of the object. And to find the area of, say, this triangular face here, you need to know the height of that triangle, which is where this slant height comes in handy. All right, so now let's actually work through an example like that. If I have this pyramid here, and the vertical height from tippy top to the center of the base is 6 inches, all right, that here, height equals 6, and then half of the distance across the base here is 3 inches, so I'll put B equals 3. Okay, that's interesting. Then that forms a right triangle, which means we can use the Pythagorean theorem to find this unknown length right here. That is going to be our hypotenuse, or our C. So what I'm going to do is I'm going to redraw this triangle in a very 2-dimensional representation to make it easier for me to see. So here's my right triangle, and I've got 3 inches down here and 6 inches up the side. And I want to find out C, my hypotenuse. You guys can do this problem. The hard part isn't doing the math. The hard part is visualizing where these lines are going. So now it's simply a matter of plugging them in. A squared plus B squared equals C squared. A is, it could be either of these legs. Let's say it's 6. So we have 6 squared plus 3 squared equals C squared, which is 36 plus 3 squared is 9, and that's going to equal C squared. Add those, oh my gosh, this pen's driving me crazy. I'm really sorry for all those extra lines. Add these together and you get 45 equals C squared. And to cancel out that exponent 2, you are going to take the square root of each side. And we've got to take this 45 and do a lovely little factor tree. 45 breaks down into 9 and 5, 5 being a prime number. And 9 breaks down into 3 and 3, which are also prime numbers. One of those threes is an evil twin that's going to murder the other one and then run away to the outside of the square root sign, leaving a 5 all by itself on the inside. So C in this case equals 3 times the square root of 5. That is the slant height of this pyramid. And if you wanted to get an approximation, you could do 3 times square root 5 in a calculator, and it would give you a decimal number. That would be an approximation for the length of that in inches. All right, so now let's talk about diagonals in a prism. This is a little bit trickier. If you want to find the diagonal length of a prism, what you're actually looking for is from one corner to the far opposite corner back there. So the line that kind of goes through the center of our rectangular prism. Once again, it's not difficult to do the math, it's difficult to see the visualization. So in order to do that, first, I need to know what this length is, this diagonal across one of the faces of the base. Because what I'm going to be doing is making a right triangle out of one of my edges and the diagonal of the bottom face so that I can find this hypotenuse here, which will tell me the diagonal of the entire prism. So let's start out with that. We're going to use Pythagorean theorem, a squared plus b squared equals c squared. And we're going to be doing it for this bottom triangle here, which I'm going to redraw to make it a little bit easier to see. It's simply a right triangle. If you're looking down from on top of this, you'd see the right triangle there, with a leg of 10 and a leg of 4. And I want to find my c, which is right here. So a squared, it can be 10 or 4, so I'll do 10 squared, plus b squared, which would be 4 squared, equals c squared, which I don't know. Okay, so when I go to simplify this, I end up with 100 plus 16 equals c squared, which gives me 116 equals c squared. And of course, I take the square root of both sides. So c should equal the square root of 116. But I've got to break that down. 116 is 2 times 58. And 58 is 2 times 29. 29 is a prime number. So I'm left with 2 times 2 times 29. One of the 2's murders the other and then runs away. So I end up with a 2 on the outside. And on the inside, I have the square root of 29. And that gives me my value for the diagonal of the base of this rectangular prism. Now that I've done that, on this page, I turned it into a decimal for you, 10.8, and we'll do the rest with decimals. Now that I've done that, second, I have to find the diagonal of the entire prism by using the diagonal of the bottom face and one of the edges. So this is the shape I'm looking for. I'm looking for that line. And I know that this vertical line here matches the length of this line here. They are both going to be 8. I know that because in all rectangular prisms, that's true. The height in one place will be the height in all of the places. And now I just use Pythagorean theorem again. I have a squared plus b squared equals c squared. I have my 10.8, which is this line right here. I'm going to square that. And then I have b, which is the other leg of my right triangle here. So I'm going to take 8 and square it. And that should give me c squared. And I'm looking for c here, remember. I'm looking for this hypotenuse, this c. And 10.8 squared, I actually know from the last one. Remember we said 2 times the square root of 29, and I turned that into a decimal for you. But when I square that, I go right back up to 116. So that 10.8 squared is going to be 116. And then I have 8 squared, which is 64, equals c squared. And this is going to be 180 equals c squared, and I'll have to take the square root of both sides. And I'll just do that for you real quick because we're running short on time. That is going to end up being 9 times 20, so I'll take a 3 out and a 2 out. 6 times the square root of 5, I think. I'll double check that. All right. Yep, that's right. So our diagonal of the rectangular prism is 6 square root of 5. Now, for your reflection, I have here, this is actually a pentagonal prism because the bottom surface is a pentagon, but you solve it just the same way as the other pyramid we solved. I want you to find the slant height of the following pyramid that has a vertical height of 10 feet and a horizontal measurement of 4 feet from the edge to the center of the pyramid. So that one right there is 4 feet, and I'm looking for you to find this vertical height here. All right? I will see you tomorrow, guys, and I can't wait to see your responses in Edmodo. Bye-bye. Oh, your responses in Edmodo, I want you to leave in radical form. So simplify it as a radical. I don't want any decimals.